Hey, how's it guys? In this video, we're going to learn how to build an Ollama desktop app using Python. So before diving into the tutorial, let me just give you a quick demo of the application that we'll be building, and as well as showing you the functionalities that we're going to implement into the app. So these two apps are identical. The only thing that's different is this one I have applied the CSS style sheet. So I just want to show you that we can apply different skins style to the application as well. Now right now I already enabled the Ollama server. So let me turn off the server real quick. Oh, I should turn that off. So my bad. All right, so if I go and run the application, and by default, it's going to check if the server is running. And because I already shut down the Ollama server, so I'm going to see this Ollama offline status. If I go and turn on the server, or enable the server, and right now we're online. On the top, we have this drop-down menu. And this drop-down is going to list all the available models that you have installed. Inside the application is going to be a very simple prompt and response application. I'm not going to build a chatbot. That's going to be for a later tutorial. For now, I just want to show you what we can do with Ollama's API, as well as how to create a simple desktop app. I'm going to choose a model here. Now, just FYI, because my PC is running on a pretty outdated GPU, so when I run the model, it's going to be a little bit slow. But if you have a newer GPU, then the response time is going to be a lot faster. Now here I'm going to give a simple prompt. Where is Chicago located? And here I can either click on the generate button, or I can use the shortcut Alt-G to press the generate button. And within 9 seconds, then it's going to return the response in the response text field. And here in the start bar, we're going to display the information such as the duration, how long the request is going to take, as well as the total token usage. So for this request, we use approximately 100 tokens. Then on the top, we have the menu. We can save the logs, or we can exit out the application. So just an FYI, the save feature is going to save all the prompts and response that you have performed throughout this session. So for example, let's say you perform 5 different prompts that generate 5 different responses. And when I save the log, it's going to save all 5 transactions or all 5 requests. Until you click on reset, then it's going to reset the session. Now the view and help menus, I'm adding there just for demonstration purpose. These 2 menu items, they don't do anything. And the last one is going to reset to restart the session. Other than that, that's going to be the entire functionalities of this application. Oh, and here we can resize the window between the top text box and the bottom text box. Now this is going to be version 1, but in the future I'm going to add additional functionalities to the application. Now, the second item that I want to discuss before we dive into the tutorial is the benefits. So why do we use desktop application over web application? And why do we use Ollama first using OpenAI or Google's Gemini AI? So the first reason is that Ollama is free, but the downside is that you don't get the performance as OpenAI or Google's Gemini. So based on your PC specs, it may take a little bit longer than using OpenAI's API or Google's Gemini API. The second benefit is that you can run this offline. You don't need to be online to run the models. And using desktop app, the app will be able to access your PC's hardware directly. So it's going to run a lot faster than web apps. And the fourth reason is that if you need to run testings on various models, then you can do that pretty quickly using a desktop application versus using web app, because you can quickly customize the functionalities comparing to web app. And the last two reasons are data privacy and security, as well as customization and specialization. You can customize the application based on your need or based on your use cases. Now that's going to be everything I'm going to cover for the intro. Now let's dive into the development. All right, so I'm going to launch my terminal, and I'm going to do everything from scratch. So you're going to see the entire step-by-step development. All right, so here I'm going to create a Python virtual environment that's dedicated to the development project. I'm going to name the environment tutorial Ollama app, and that should be fine. Tutorial Ollama app, and enter. And here I'm going to go into the folder. It should be right here. Then I'm going to set it into the folder. Then activate the environment. Now for this project, I'm going to install several dependencies, but the first one is going to be the Ollama Python package, and to display the response in Markdown format. So this one's optional. You can display the output as regular plain text. But for me, I like to display in Markdown, so that way that is going to format the output more nicely. And to build the application GUI, we'll be using PyQt6 framework, and enter. Now, once we install the dependencies, let me move over my files. Now, this one is going to be the CSS style sheet. So the only thing that I did here is I changed the Windows background to this darker blue or navy blue. And for the label and start bar, I changed the default color to this outlet blue. And that's everything for the CSS style sheet. Now, the other files that I created is this pyollama.py module. Now, this one's for testing, so let me delete the code block. Inside this pyollama module, I created three functions. So one function to list the models that you have installed. The other function is going to run the model. So in this case, we're going to use the generate method. We're going to provide the model ID. And we don't want to stream the content or stream the response. And this function here is going to convert the duration unit created by the Ollama's API. And this function is going to convert that to regular seconds. All right, so let's go back. Let me shut down the app. Let's go ahead and create the app.py file. And let's open the file. Let's go ahead and activate the environment. So select the target environment. All right, so let's go ahead and import the libraries. Now for this app, we're going to import the system module, time module. The JSON module is going to store the log in JSON records. And here's the import statements to import the GUIs and the core features from PyQt's framework. Then we're going to import the Markdown module. Now here, the reason why I import the HTTPX library is because Ollama's API uses HTTPX as the backend to make the request codes. And I need to use HTTPX library to capture the exceptions. Then from PyOllama, we're going to import run model, convert nanoseconds to seconds, this model's names methods. Oh, and one more thing. So to embed the icon, for copyright purpose, I'm going to use my YouTube channel logo. So which is going to be this icon right here. Let's go ahead and create a class to construct the app window. I named the class app window. And you can see this app window class as the entry point or the main window. And from the app window class, we're going to pass QWidget as the parent class. And here I'm going to set the minimum size of the window. So this is going to be the window width and height, window title, window icon. Now, if we want to apply CSS style sheets to a specific object or a specific widget, we need to create an object name. In this case, I'm going to name the window as main window. Otherwise, if you apply the CSS style sheet or CSS properties to the widgets, so for example, if we look at line 6 to line 7, if we specify the class, then it's going to apply the CSS property to all the widgets that uses these two classes. First, by using object name, we can set the CSS property to a specific widget. The setStyleSheet method here is going to override the font size property. In this case, I'm setting the font size to 16 pixel. And to organize the widgets, we'll be using different layout controls. So like these two. So we have horizontal box layout manager and vertical box layout manager. And the difference between the two layouts is the orientation on how the widget is going to get inserted. So here I'm going to use vertical box layout as the main layout manager. So I'm going to insert the widgets and layouts vertically. And because throughout the development, I'll be using multiple layouts. So I'm going to create a dictionary called self.layout to store all the layouts that I'll be using. Then we need to use the setLayout method to tell the app window class or tell the app window that which layout we're going to use as the main layout. And to store the log, I'll create an empty list called self.response log. I'm going to insert my entry point, which is going to be the main routine. And let me fix the spacing. All right, so let's look at the entry point. When I run the application, I'm going to list all the models into this models object. Now, if the Ollama server is offline, then we'll run into this httpx connection error. And if we run into the exception, we're going to set the models as an empty list. Then we're going to create a flag to indicate whether or not if the Ollama server is online or offline. Then we're going to construct a queue application instance. So this is going to be the application process that will be running in the backend. So there are multiple layers that we can apply the CSS style sheet. So we can apply the style sheet on the app level, or the app window level, or the individual widget level. Now, these two lines is going to construct the app window instance. Then we need to use the dash method to display the window. Now, from this point, your desktop application is still running in the process. When we terminate the application, we need to run the system.exit, and we're going to reference the process ID of the app object. So this is going to completely terminate the process. All right, so let's go ahead and run the app, and let's look at the window here. So we have a blue screen and nothing else. Now we're going to insert the widgets. So when I insert the widgets, I like to create a separate method to organize the widget insertion. And I'm going to name the method initUI. And in the constructor, we need to call the initUI method. Now, if we look at the application again, so the first section that we're going to create is this model section or model row that contains the dropdown. So I'm going to create a horizontal box layout called model. Then I'm going to add the layout to the main layout. So we can stack the layout on top of another layout. Then I'm going to create my label. I'm going to set the label width to 60, followed by the combo box. I should name this to something else like combo model to make that more recognizable. Anyway, I'm going to set the combo box width to 250, and it's going to be fixed width. Then I'm going to add the models to the combo box. Then I'm adding the widgets to the model layout. Now, when you insert the widgets directly to the layout, it's going to use up all the spaces. And I want to leave empty spaces to the right to make the appearance a little bit nice. So here we can use this add stretch method to push the widgets all the way to the left. So here, if we take a look, and we have our combo box and the label. So far so good, nothing crazy. Now here's the tricky part. So right now, if I expand the window, you can see that all the widgets, like the text boxes, are resizing correctly. So the workaround here is that I created two classes. So this class here, plain text pays Q text edit. So this is a modified Q text edit widget, which is the text box. So basically, we can modify the behavior of a widget by referencing the built-in methods. So this plain text paste Q text edit class is going to disable the formatting when you paste a text from an outside source. So for example, if you use the Q text edit widget as the text box, and if you copy paste a text block from a web page that containing different formatting, then when you copy over to the text box in the app, those formatting will get convert over. And I want everything to be pasted as just regular text. So here I need to first of all set the auto formatting flag to auto none. Then I need to modify the pasting behavior. So I'm referencing the key process event, which is a built-in event that tied to the QTextEdit class. So the E argument stands for event. So I'm checking the event. If the event is a pasting event, then I'm going to basically copy the content from the clipboard instead. Otherwise, I'm going to return the event without modifying anything. Now the label text edit class. So this class is used to attach the label and the text box together. So these two items here. And the reason why I need to do that is because it was creating extra space on the top. I don't know why. And this is a workaround that I was able to figure out. All right, so let's go back to the init UI method. Let's complete the text box field. Now let's insert the text boxes. For the prompt input, I'm going to create a plain text paste Q text edit object. Then I'm going to insert the label. So if we go back to the class here, so we have two arguments, the label and the text edit object. So label here is going to be just the caption. Inside the constructor, I already predefined the Q label widget. And this one's going to be the text edit widget itself. Now for the response field, so this one I'm actually going to use Q text browser widget. And the difference between Q text browser and Q text edit widget is Q text browser is able to render the HTML markup. Then I'm going to create the label text edit window. I'll name the output as prompt response window. And to be able to resizing the area between area 1 and area 2, we have this dragging, I don't know what I call it. In PyQt, we call this a splitter. I don't know if that's the correct terminology, but I'll have this splitter or this item right here that we'll be able to use to resize in the area between top and bottom. So I'm going to create a QSplitter widget, and I'll set the orientation to vertical. I'm going to add these two windows to the splitter. Now, to prevent either area to close completely, I want to at least leave some visibility to those windows. So I need to use this setClassable method. I need to provide the widget index or location index. I need to set the value to false. So here we have widget 0, which is going to reference in this window here. And 1 is going to reference in this widget here. All right, so let's take a look. Oh, I forgot to add a widget to the main layout. All right, so we now have the text fields that we can enter the prompt and to display the response. Now we need to insert the buttons to run the model and to resize the fields. For the buttons area, I'm going to create a separate layout to organize the widgets. So I'm going to name the buttons btn generate and btn clear. And here I'm inserting the widget class QPushButton, and it's going to be the caption. And by inserting the ampersand symbol, this will automatically generate the shortcut key to the letter that you specified here. Then we're going to assign the self.runModel method to the click signal. Now this line here is going to set the button size, and it's going to be fixed width to 200. And here I want the clear button to be a little bit smaller than the generate button. I'm going to set the fixed width to 100. And again, the setup is basically the same, except that here I'm assigning the reset method to the click signal. Now let's create the reset method first. All right, so it's a pretty straightforward method. We are basically clear the text field and the message bar, or the status bar, not message bar, status bar. And I haven't created this widget yet, as well as reset the response log list. For the run model method, so here's the source code. I'm getting the model ID from the combo box. Then I'm going to grab the prompt from the prompt input text field. And here I'm checking whether or not if the prompt field or the prompt output is empty. Now, just in case, if the user did not provide a prompt, they want to display a message. Prompt is empty, please enter a prompt. And I'll be using the status bar to display the message. Then I'm going to run the run model function, and I'll provide the model ID and the prompt. The response is going to be a dictionary. Oh, and here's the exception capture. So because the response object is a dictionary, we can grab the output from the response key. And I'm going to remove the spaces on both ends. And I forgot what this extension do from the markdown function. You might have to do a quick Google search on this one. But basically, the markdown function is going to convert a markdown string into HTML. They want to append the response record to the response log object. So here I'm creating a dictionary with a model ID, prompt that we use, the response, duration, and the token usages. Then I'm going to append the output to the prompt response text box. Then using the status bar, I'm going to display all the relevant information that I want to display to the user. And that's going to be the run model method. All right, so almost finished. And let's finish the app. Oh, so here I forgot to add the buttons to the layout. So here again, I want to push the button to the right. So I'm going to call the add stretch method first. Then I'm going to insert the buttons. For the status bar section, I want to create a hyperlink that is going to direct to my channel's page. So using QLabel widget, we can insert the hyperlink. So here's the URL, and here's the label color, and here's the text that I want to display. Then I'm going to insert the status bar. Now within the status bar object, we can use the add permanent widget method to add additional widgets to the other side. Then we're going to add the status bar to the main layout. Let's go ahead and insert the message to show whether or not if the Ollama server is online or offline. So we can use the Ollama offline flag. Then if the flag is true, then we know that the server is offline. Otherwise, it's going to be online. So very straightforward if statement. All right, so this is 80% of the interface, and we still have the menus left. But actually, let's do this. I'm going to test the functionality. I'm going to type hi and generate. And we'll get a response back pretty quickly. And reset's going to clear everything and the hyperlink. Now to add the menus. So I'll create a separate method to perform the menu creation. To create the file menu, we'll be using the Q menu bar widget. And from the menu bar widget, in this case will be the menu bar object, we're going to add the main menus, file, view, and help. And here we need to reference the main layout that represent the Windows interface. Then we need to use the set menu bar method. And we'll supply the menu bar object that we're going to use to represent the menus of the application. Now here we need to, let me insert a bookmark right here. Now here we need to code the method add menu. These two statements are adding the submenu to the file menu. So we need to reference the file menu, then we want to add the submenu. Then we need to use the add action method to create a submenu. So it's going to be save, and here's the method that I want to execute. And we can also assign a shortcut key. In this case, I want to assign a shortcut key to Ctrl S to automatically save the log. And this one's going to be the exit action to close the application. Now this is going to be the last step to create the save method to save the log as a JSON file. So let's put that here. Now if we look at the save method, we're going to create a timestamp. Then we're going to construct the file name. Now if we didn't run any model in the session, then we know that the response log is going to be empty. Then we can display a message, no response to save. Otherwise, we can dump the object. In this case, will be a list of dictionary objects using JSON.dump method. Then display the file location. All right, so that's basically everything. So we're done with the application. Now I'm going to save the file. and launch the file, the application. All right, so first I'm going to use the shortcut Ctrl S to attempt to save the file, and we'll get no response to save. Then I'm going to enter a prompt. Tell me a joke and generate. And here's the response. Now, as I mentioned before, this is going to be great for testing different models. So let's say if you want to use the same prompt